Hello dear students, thanks to all for watching my lecture. Today I am delivering my lecture on the topics of physics first paper. Chapter name is work, power and energy. This is the part of the first paper of intermediate. If you are the student of admission test, then this lecture will be really very helpful for you. Today I am trying to develop the basic concept and give you some important example that will really develop yourself to find out the work done. Okay, now we try to discuss. At first, here has three parts of this chapter. One is work, power and energy. Combined three part of this special. The name of this chapter is work, power and energy. Always try to understand. Here has three part. One part is work, power and energy. Part 1, in the part work, in case of the work part, we just try to find out the work done for different type of the case. Okay, at first we discuss about work. My dear student, try to understand. If you find out the work in our physics chapter, then in case of the physics, if you want to do some work, then you must have to confirm two things. One is applied force and another is displacement. Always try to remember that you must have to take the displacement along the direction of the force. Okay, otherwise it is not possible to find out the work done by applying force. Okay. In case of measuring work done, at first we have to clear that work done measure can be two types. One is for constant force and constant force, and another is variable force. That is really very important. Always try to understand that if you want to measure the work, then it can be two way. One is for the constant force, another is variable force. In case of the constant force, at first we have to discuss how we can find out the work done, and then we discuss in case of the variable force, how can we measure the work. My dear student, in case of the constant force, suppose this is the reference line and here has a object. Suppose this is the position of the object. The position is right now A, and if we apply the force on this object, this direction, as we know force is a vector component, so we can write here, this is the force, this is the vector. As force is a vector component, so we can write by this way, because of applying force F, this body go to point A to B. Okay, here try to understand, as here displacement occurred along the direction of the force, so we can write this is the displacement. We also know displacement is also a vector quantities. My dear student, here try to understand, the name of this force is constant force. Why? Because the magnitude of the constant force cannot be changed for moving the object point A to B. Okay, suppose if the body go from A to B, always we apply 50 Newton force for AB section. My dear student, because of this force, the body moves from A point to B. Because of that reason, the name of this force is constant force. This is the best example for us. Now, how we can measure the work. My dear student, always try to understand, if you want to measure the work, at first you must have to have to clear that work is a scalar quantity. Work is a scalar quantity. In our physics second chapter vector, here has two special operation. One is scalar product and another is cross product. Okay, my dear student, these two operation is really very important for us to find out the scalar quantities from two vector quantities, and another operation is cross product. These products also very important for us to find out the vector quantities from the two vector quantity. Okay, my dear student, as work is a scalar quantity, work is a scalar quantity. Because of that reason, if we find out the work from two vector component, then we must have to use the dot product. Why we use dot product? Because dot product is a special operation in physics. This special operation give you the scalar quantity. Okay, our scalar quantity is work. As work is a scalar quantity, because of that reason we write this equation. Okay, after solving this equation, we know from the dot product the magnitude of f and magnitude of s and cos theta. This is the equation for measuring work. Okay, my dear student, now our duty is to find put the value of f and value of s and value of theta. What is the theta? Theta represent the angle. Always try to understand here. Theta always represent the angle between force and displacement. My dear student, always try to understand the angle. What is theta? Theta always represent the angle between applied force and displacement. Okay, my dear student, here if we reshape this equation or rearrange this equation, then we also can find two things here. Okay, suppose if this is the equation, suppose if we write this equation, f is w is equal to f s cos theta. My dear student, we can rearrange this equation by two ways. One way is f into s cos theta, and another way is f cos theta into s. This is the two special way to rearrange this equation 1. My dear student, what the rearrangement give you special message. This two way of rearrangement give you a special message. What is the special message? Now I am try to understand and clear you. Okay, my dear student, our basic definition of the work for applied force and perpendicular displacement. Okay, my dear student, you must have to clearly understand that if the displacement and direction of displacement and direction of the applied force always same. Okay, if the direction of applied force and direction of displacement is same, then only for this special condition you can able to measure the work. Here the equation give us this special message. This is the direction of the force and this is the direction of the same. In our physics, the definition of work, the multiplication of the product and the displacement taken from the direction of the force is called work. Okay, my dear student, now we give you two scenario here. Okay, suppose if this is the body A, suppose we at first we apply this diagram force here, this is the point A, and if this point do not go along the direction of the force, suppose this body comes here, okay, this body comes at point B. We know from our definition of the displacement, the minimum distance between initial to final position. This is the initial position and this is the final position. So this is the direction of the displacement. My dear student, as this is the direction of the displacement, but for measuring the work we must have to take in the displacement along the direction of the applied force. Now we can do this. As we know, displacement is a vector quantities, so here displacement create an angle between the direction of displacement and applied force, direction of applied force and displacement. Okay, now this displacement create an angle along the direction of the applied force is theta. So displacement can be divided into two ways. One is S cos theta, another is S sin theta. S sin theta. This is displacement, this is one component of displacement, this is the another component of displacement. As displacement is divided into two parts here, so if we measure the work here, suppose this is the equation of the work W. At first we have to take the force and we take always displacement along the direction of the applied force. This is the displacement that is along the direction of the applied force. My dear student, I think that all of you clearly understand. So this equation give this message that we rearrange this equation by way. Okay, my dear student, F into F cos theta give you the special message. This is the applied force and this is the component of the displacement. Okay, my dear student, horizontal component. Okay, as this component along the direction of the applied force, but this component cannot the component of displacement cannot use our measuring work. Okay, now I will give you the another situation. Suppose this is the object. If we apply the force of this object in this way, and if this body go from point A to B, now as we apply force this direction, but the body do not moves along the direction of the applied force, the body moves this direction. This is the displacement, because we know this is the minimum distance between initial point to final point. Now our duty is to measure the work. Here we can see applied force make a angle with the displacement. So we can divide the applied force into two parts. One is F cos theta, another is F sin theta. According to our definition, if we want to measure the work, then at first we write W. We need the force and the displacement. The component of the force is F cos theta, and because of this component here, the direction of displacement is same. Or because of that reason, we write this component. We do not write this component. My dear, I think that all of you clearly understand. This is the powerful equation to measure the work. W is equal to F cos theta in case of the constant force. My dear student, always try to understand. Here has two special notation involved in this equation. One is F into S cos theta, another is F cos theta into S. What is this? This give you the special message. This is the force and this is the component of the displacement along the direction of the applied force, and this is the component force, and because of this component force the displacement occurred in this direction is S. My dear student, I think that all of you clearly understand. If you have this knowledge and you if clearly understand these things, then it is really very easy for you to measure the work in case of the constant force. Now I have set another condition here. My dear student, my condition is if we put the value of theta for different cases, then we get the different result. My dear student, as our what is our condition? Our condition will be really very important. Suppose our equation is W f s cos theta. This is our basic equation to measure the work. My dear student, our first condition will be if the here we can see three things here. One is f, s and theta. If f is a constant and displacement also a constant, then theta will be changeable or theta will be variable. So value of theta depend the work actually here. Okay, if these two things is a constant, so we can remove this two part and equal sign, so we can write this equation. So work done actually depends upon the value of cos theta. If the value of cos theta increase, then work done also increase in case of the constant force. If the value of cos theta decrease, then work done will be decrease. And value of cos theta actually depend on the value of theta. Okay, now because of that reason, at first we said the condition 1. Our condition 1 is if value of theta is 0 degree, then what will be the work done? F is cos 0. W is equal to, as we know, cos 0 means 1, so we can write here Fs. So this notation give us the special message. This is the maximum work done. Okay, when the work done will be maximum, if the value of theta is 0 degree, then 0, then work done will be maximum. The maximum work equation of the find out the work done is Fs. In these cases, for getting the maximum work, always try to understand, always if this is the applied force and if this body comes here and this is the direction. When the applied force and the direction of the displacement is same, here the angle between applied force and direction of displacement is 0. Because of that reason, in this scenario we get the maximum work. Okay, our two condition is if we put the value of theta is 90 degree, then work done will be F is cos 90 degree. Okay, my dear student, the value of cos 90 degree is 0, so here work done will be 0. This is the special notation for us. Okay, already we get to special or pretty equation. Here we can see if the value of theta is 90 degree, that means the angle between the applied force, and the displacement, if 90 degree, then the work done will be 0. This scenario, now we try to understand to you. If this is the circular path and if here has an object, always try to understand, if you want to rotate this object around this circular path, then we need a force. The name of this force is centripetal force. Okay, the direction of the centripetal force always to the center of the circle. And always try to understand, here has two type of displacement. One is when any kind of the object rotate around the circular path, then here has two types of the displacement involved in this situation. One is linear displacement and another is angular displacement, and the centripetal force is a linear force because the direction of the centripetal force always toward the center of the circle, as the direction of this force is a straight line and because of that reason this is the linear force. Another force also involved here. The name of this force is torque. Okay, my dear student, we know when any kind of the object rotate around the circular path, then this object get involve two types of the velocity. One is linear velocity and another is angular velocity. Along the at any point on the circle, at any point on the circumference of the circle, if we draw the tangent, if this body rotate this here, if we draw here a tangent, this tangent represent the direction of the linear force. Okay, this is the linear velocity. This is the direction of the linear velocity, and because of this linear velocity, here has a displacement. The name of this displacement is linear displacement. We write this displacement is very small. Why? This is also a region, because if we take the very small part of a circle, this small part look like as a straight line. Suppose if you think this part of the circle and this cross-sectional part of a circle represent the straight line. Because of that reason, this displacement will be linear. As the force is a linear force and displacement also linear here, and the angle between the direction of the displacement and direction of the force is 90 degree. In this situation, the work done will be 0. So, my dear student, always try to understand, when we rotate any kind of the object around a circular path, because of the centripetal force, there is no work done here. Okay, suppose Earth rotate around the sun, because of the centripetal force, there is no work done involved here. Okay, my dear student, another force also involved here. The name of this force is torque. Okay, torque is one kind of the special force. Because of this force, any kind of the object rotate around the circular path. When the object rotate around the circular path, then here also involves a velocity. The name of this velocity is a angular velocity. As this velocity is a linear velocity, and because of linear velocity, here occur linear displacement, and because of the angular velocity, here also angular displacement. If the value of the angular displacement is very small amount, then we also can measure work. Suppose our equation is to find out the work done W, we need force. Here as we take the displacement is angular displacement. Suppose if this body go here point A to B, then here occur a displacement. Suppose the value of this angular displacement is d theta, so we can write displacement d theta according to our equation. Okay, my dear student, according to our equation, we can measure work done by this equation. W is equal to tau d theta. What is give you this message? This is the same message from we get this equation. Here we can see here has a force. The name of this force is torque, and here has a displacement. The name of this displacement is angular displacement. This is the torque. Torque is one kind of force, and this is a angular displacement. Okay, my dear student, I think all of you clearly understand. Okay, now our third condition is very important for us. If the value of theta is 180 degree, then what will be the work done for this situation? My dear student, according to our equation 1, f is cos 180, we know the value of 180 is negative minus 1. Because of that reason, we can write W is equal to Fs. My dear student, this is the another equation to measure the work here. Here we can see this work done is negative, so we can write here negative work, and this is the positive work. My dear student, in our physics, here we can see three types of the work involved here. One is positive work, positive work, and another is 0, third one is negative work. My dear student, as we can see three types of the work here. So we just erase some of, we just clean some space here. Okay. My dear student, now our duty is to understand what is happened here actually. My dear student, as we know, work is a three types. So we can write here work. One is positive, zero, and negative. In case of the positive work, we must have to set special conditions here. What is the special condition? The special condition is the value of theta will be exactly 0 or greater than 0 and less than, not 90 and less than 90. So we can write the notation by this way. If the value of theta greater than or equal 0 degree and not equal less than 90 degree. My dear student, this is the special notation. This special notation gives us the special message to measure the work. In this situation, in this condition, always we get the positive work. If the value of theta exactly 90 degree, in this situation we get the work done is 0. But in case of the negative work, if we set up the value of theta, then we get greater than or 90, greater than 90 not equal, and less than or equal 180. In this situation we get the work negative work. My dear student, I think that all of you clearly understand. Here has we get three types of the conditions. One is positive work, another is 0, and third one is negative work. Now our condition already fulfilled, and we set up different type of the condition in our equation, and we get different type of the range for find out the work, in which range the work done will be positive and in which range the work done will be negative. My dear student, I think that all of you clearly understand. If you understand this section, then I go to the next section and I will give you the some example of the constant force for measuring work done for the constant force. Now I will give you this one or two example right now. Okay, my dear student, always try to understand for measuring force, measuring work, you must need to understand, we must involve force and displacement. Suppose I take you example 1. Suppose this is example 1. Okay, example 1 is suppose this is a body. Suppose this is a body. Suppose we apply force here. F is 2i cap plus 3j cap plus 4k cap. As this is the force, the direction of this force is this, and position of the object is 2, 1, 3. Okay, this is the position of the object. And if this body comes here from point A, suppose the name of this point is B, 4 minus 2, 8. Okay, my dear student, try to understand. This is the initial position and this is the final position. Okay, as we can see here, the direction of the displacement is along the direction of the force. As that force is given vector and displacement also given vector. So if we measure the work, then at first we write the equation F dot S. Okay, now for measuring work, at first our duty is to find out the displacement. Here has coordinate for initial position and coordinate for final position. We know from our vector chapter, we write can any vector if initial point and terminal point is present, then we just take the difference along x-axis, difference along y-axis and difference along z-axis. Suppose the difference, we take difference along x-axis. Suppose we at first write 4. Why we write? Because this is the terminal point of the displacement. 4 minus 2. 4 minus 2. This difference occurred along the direction of the positive side of the x-axis, so we can write I cap. Okay. Now we write here plus. This point is minus 2 minus 1. This is the difference along the direction of the y-axis. So because of that reason we can write here j cap. Now we take the difference along the z-axis. 8 minus 3. This is k. I think that all of you clearly understand this notation. If you fail to understand why we write this equation, then please go to our physics first paper chapter 2 vector, and the section of displacement you can easily find why we can write this. Okay, if you fail to find out this lecture, then please please go to our description section, and here I put a link. You can easily find out this lecture by clicking on the link. Okay, my dear student, thanks to all. If you face to understand this situation, if you cannot catch these problems, then you just you write your comment on the comment section. I am try to give you the clear concept that will be very helpful for you to understand. Okay, my dear student, now we write this 4 minus 2 means 2 I cap. This is minus 3 j cap. This is plus 5 k cap. Okay. Now we put the value of f, 2 I cap plus 3 j cap plus 4 k cap dot 2 I cap minus 3 j cap plus 5 k cap. My dear student, we know the dot operation 2 and 2 4 plus minus minus 3 3 9 plus 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 20. Okay, 25. No. This is minus 5, 15 joule. Here, how much work done here? 15 joule. 15 joule. My dear student, I think that all of you clearly understand problems number 1. Now we go to the problems number 2. Our problems number 2, if the force is 2 I cap plus 3 j cap and z k cap. Okay, our question is, if the work done because of this applied force and this displacement is exactly 0, then what will be the value of z? Okay, my dear student, our question is, if we apply the force F and displacement occur A to B and displacement occur A to B and work done is 0. Our question is, if the work done is equal to 0, then find out the value of z. Okay, now our duty is to put the value to as we know from our equation for measuring work, as we know work done, we can write F dot S. Okay, so at first we write the value of force 2 I cap plus 3 j cap plus z k cap. Okay, now we put the dot sign here. Now we write displacement 2 I cap minus 3 j cap plus 5 k cap is equal to 0. My dear student, if we complete this dot product, then we get the work, then get the value of z. Okay, now this is 4 plus minus minus 9 plus 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 5 z is equal to 0. Okay, as the value of this minus 5 plus 5z is equal to 0, 5z is equal to 5, so the exact value of z will be 1. Sorry, my dear student, I think that all of you clearly understand the exact value of theta, sorry, exact value of z will be 1. If the value of z exactly equal to the 1, then in this situation, by the applied force F and because of this displacement, there is no work done here. Okay, then here angle between the force and displacement is 90 degree in this situation. Okay, my dear student, I think that all of you clearly understand. Now I also take you another example. My another example is like this. Okay, my dear student, my third number of example, suppose we apply force here by this direction. The amount of force is 50 Newton. Okay, here has a friction, the coefficient of the friction on the surface is 0.5, and if this body comes here from point A to B, suppose the displacement between A to B is given 10 meter, S is 10 meter, and angle is 30 degree. Then our question is find out the work done in case of the applied force. Work done, number 1, work done for applied force. Applied force. Number 2, work done for friction. My dear student, at first I give you the example and I give you a special description, then we try to solve this problem. Suppose this is the direction of the applied force, and if this surface is rough, suppose this is the rough surface, if this body go from point A to B, then opposite direction of the applied force here involves a friction. Suppose the name of this friction is kinetic friction, Fk. We know if the body move from A to B, then because of the rough surface here has a resistive force. The name of this resistive force is kinetic friction. My dear student, now we measure the work done with the help of this equation, Fs cos theta. This is our equation. This equation gives us the message to measure the work for every situation. Now, in case of this force, if we want to measure, suppose the amount of force is 10 Newton and displacement is 5 meter here. Now, we put the value of 10 Newton and displacement is 5 and the displacement is 5 and angle between the applied force and displacement is same because we put here 0. So 15 joule 50 joule work done, positive 50 joule work done here because of applied force F. Now we measure the work in case of constraint 4. In case of this force, okay, we know our equation. We write F replaced by Fk. Why F replaced by Fk? Because we now measure the work done for Fk, frictional force. Displacement